Hello everyone, how are you all doing? So before we start the session, first quickly let me know if I'm perfectly visible and audible to you or not. Quickly you can write in the comment section below and I'll understand. Yes. Alright, Sushmita, hello ma'am. Yes. We have Abhijit here. Yes. Amna Mazhar Ali. Bhanu is here. Yes. Alright, Papiya Das. We have Sankha. Yeah. Raja Raman. Yes. Umar Anis. Yes. Adhira is here. Hello ma'am, how are you? I'm good Adhira. How about you? Yes, Bishal Day is here. Sharda. 9B16 Krisha Modi. Hello ma'am. Alright, so we are all set, so we can start. So first of all, a very warm welcome to yet another wonderful session. So this is the second session on the polynomials. So today we'll be discussing factorization of the polynomial. So without wasting any more time here, let's start the session. Alright, so we have already learned about the division of numbers, right? We all know it, how to do that. But let's just recall how to do division of polynomials, right? So let's suppose that this is the polynomial that we have 3x squared plus x minus 1 and it is divided by x minus 1, right? So simply what we do is we multiply x with 3x, we get 3x squared, and we multiply 3x with minus 1 also, we get minus 3x. We change the signs and we get what? We have 4x minus 1 at the end. You take minus 1 down. And then we multiply this x with 4, positive 4, you get 4x. Positive 4 is multiplied with minus 1 also, you get minus 4. And at the end you get the remainder as positive 3. So this was basically the long division method by which we used to find out the remainder, right? Now let's take an example to understand this. So we have to find out the remainder when fx is divided by gx, right? So fx is given to you, gx is given to you, right? So simply just write down here, this is the dividend, 2x cubed minus 4x squared minus 5x minus 3, and the divisor over here is 2x squared minus 1, right? Alright. So simply, what shall I multiply? First of all, you need to see that these are in the standard form here. This dividend and divisor both are in the standard form. By standard form, I mean that the degree should be from higher to lower, right? This should be the order. Alright, so what shall I multiply 2x squared with so that I get 2x cubed? Multiply this with x, we get positive 2x cubed, and then this x would be multiplied with minus 1 also, right? You get minus x. What do we have here? We simply change the signs. This will become negative. This is the positive sign here. Then this gets cancelled out, positive and negative, right? Minus 5x plus x, you get minus 4x. You take minus 4x squared down and you take minus 3 as well as down. Now I'll multiply 2x squared with minus 2, right? So I get minus 4x squared. Now this minus 2 is multiplied with minus 1 also, you get positive 2, right? Change the signs. What do we get? This gets cancelled out. We have minus 4x and minus 5 now. Right? Ananya, screen is not clear. Ananya, please refresh the screen once. Neha Parmar, ma'am, you teach very nice. I love your teaching. Thank you. Thank you, Neha. Thanks a lot. Deepak, it's too easy. Yes, indeed, it is easy. It's a very simple question, but gradually we will increase the level. This is just to make you understand, the basic of it. So this is the remainder that we get. So this was the long division method to find out the remainder, right? Now we will see that without performing long division method, how can we find out the remainder? For that we will learn the remainder theorem, right? Which we have derived from the division that you have already learned in the previous classes, right? We know how to do a division of numbers or of polynomials. So dividend is equals to quotient times divisor plus remainder. This is what? This is your division algorithm, right? Alright. Yes. So, Amna Mazhar Ali, why we have skipped 4x? We haven't skipped. Okay, let me just show that to you. 4x you are talking about. See, 4x is here, right? Now in the remainder we have 4x and minus 5. Now what we see here is that how do we know that this is the remainder only? That we do not have to proceed further. Reason being, we see that the degree of this divisor is bigger than the degree of this remainder. When this happens, your question finally ends there, right? So whatever you get that as the remainder. Yes, Deepak, it's like Euclid's division lemma only, right? Right? So simply in Euclid's division lemma also, when you're trying to find out the, when you're just performing the division, right? So we are doing the same thing actually. Yes, Amna, I have answered your question, right? I hope it's clear now. Alright, so this is the division that you have already learned. Now let's try to understand the remainder theorem by an animated story. So here in the story, this divisor, it depicts a person which actually cuts this apple, which is depicting this this dividend. It's depicting this apple. So this person cuts this apple, right? And when he cuts the apple, we get the quotient and the remainder, right? So the quotient is basically fully cut by the person, right? So what do we get here? We get 1/4 plus 1/4, which is actually exactly half of this apple, and the half of the part is nothing but that's the remainder of this apple, right? Prashant, ma'am, today is my birthday. Well, happy birthday, Prashant. All right, Amna. So it's clear to you, right? Okay. So this is 1/2 and this is also 1/2 of this, right? Now, so let's take a look at the mathematical statement of the remainder theorem. So what it states actually. So if a polynomial px is divided by linear polynomial x minus a, right, then the remainder obtained would be p of a, which is polynomial in a. What does this mean actually? See, if we compare this formula, let's take a look at this formula. This px is nothing but that's your dividend. This is qx, this is x minus a plus pa. Now if I compare this theorem formula with the animated characters that we have used, what we can say is that this px over here is the dividend, which is depicting the apple. This qx over here is the quotient, which is actually showing half of the apple, right? It was that half of the apple was further divided into two halves, which is 1/4 and 1/4, right? Yes. Then this x minus a, which is basically the divisor. Divisor here depicts basically a person with a knife, who is actually cutting this apple. Then we have this p of a, which is actually the remainder, which is exactly 1/2 of the apple, right? All right. So this is basically remainder theorem. This is what the mathematical statement says. And to understand this in a better way, we have used the animated characters. All right. Now we know what remainder theorem is, right? So this is the theorem statement. This is a theorem formula that we learned. Now let's take a look at the conditions for the remainder theorem. So this, I would say that you should remember this, because in grade 10th also you are going to use it. So the degree of px, right, polynomial in x, that should be greater than or equals to 1. We are talking about the dividend over here, right? Degree of dividend should be greater than or equals to 1. So it can be equal to 1, it can be more than 1. It cannot be negative, because if it is negative, it will no more be a polynomial. It cannot be 0 also, right? Because if the degree is 0, that means it is a constant over here. There is no variable. Yes. Yes, Umar Anis, ma'am, when will series for class 8 will start? Well, I would say, Umar, please subscribe the channel to get notifications, right? So we will update you regarding this. Don't worry, we are going to start class 8 series as well very soon. Okay, now take a look at qx. So degree of qx should be less than or equals to px, right? That means the degree of quotient should be less than or equal to the degree of dividend always. And what about remainder? The degree of this, which is p of a here, the degree of remainder should be less than or equals to qx. And if you remember, we did an example also just a couple of minutes before, where I showed you that why the question ended there. All right. So these are the conditions which are important for remainder theorem to work. Now let's solve a question to understand this. Yes, special day, crystal clear, great. Yes. Sai Arjun, BYJU'S is my favorite companion for learning. Wow, great. Okay, so this is the dividend over here, which is denoted by fx, and this is the divisor, which is denoted by gx, right? So we have to find out the remainder, and this time we are not going to use the long division method to find it out. Simply we will be using the remainder theorem, and it's actually much easier, I would say. So this is the gx, that's the divisor. Let's find out the 0 first. I'll equate this to 0. From here I get the value of x, that's basically 1/2, right? Okay, now what I'll do is, here in place of x, I'll put 1/2, right? So that's f of 1/2, 8 times 1/2 cube minus 12 times 1/2 square plus 10 times 1/2 minus 7, right? Just simplify this, what do we get? We get 1 minus 3 plus 5 minus 7. So we get 6 minus 10, that's going to be equals to, at the end, that would be equals to minus 4, right? So this is one way of finding out the remainder without even using the long division method, you see, right? So you see that this makes it much simpler then, because I know that few students find out the long division method, they find it a little boring or they find it confusing also. Sometimes you end up making silly mistakes when you are changing the signs. Papiya Das, ma'am, sorry because I got left from live due to network problem. It's okay, Papiya. So whatever you could not see, you can watch it later, right? Yes. Sony, yes. Can you explain how it is 1 minus 3 plus 5 minus 7? See, this is 8 times 1 by 2 cube. That's going to be 8 times 1 by 8, right? Negative sign is here. We have 12. 1 by 2 square is going to be 1 by 4. Then we have, this gets cancelled out, plus 5 minus 7, right? So this gets cancelled. That's 1 and this is 3 plus 5 minus 7. So this is 1 minus 3, right? So this is going to be what? This is minus 2, right? This is plus 5 minus 7, or you can write it other way as well, right? It's going to be the same thing. So what do we have here? We have 3 minus 7 minus 2 plus 5. You can say it's minus 4, or you can add up different way as well. That's completely fine. Yes, simple calculation, right? It's more easier, right? So this is the final result. This is the final remainder that we get. Alright, so this was about remainder theorem. Now let's learn what factor theorem is. So we'll be using the same animated characters that we used for the remainder theorem, right? So here again, this is the dividend, right? So here px is actually denoting that apple, which actually shows this is the dividend. And this x minus a, right? This x minus a, which is divisor, it is depicted by a person who actually cuts this apple, right? Yes, Sai Arjun, understood. Abhijit, understood. Sony Simon, Bishal Day, got it, ma'am. You always explain very clearly. All right, great. So, when he cuts this, what do we get? We get the quotient and the remainder. But this time you see, he has cut the entire apple, right? So, the remainder is 0. Remainder is 0 and here the quotient is basically, it is fully cut. So, fully cut, the apple is fully cut into these 4 parts. So, when it is fully cut, remainder is 0. So, I can say one thing, that the remainder is denoted by P of A over here, which means what? So, this is very important thing. When the remainder is 0, what I can say that, so let's take a look at the mathematical statement. If Px is a polynomial of degree n greater than equals to 1, remember this thing, degree has to be greater than equals to 1. Either it is equal to 1 or it is more than it. It cannot be negative, because if it is negative, it will no more be a polynomial. It cannot be 0, otherwise it will be a constant. There won't be any variable. Yes. Alright. So, I can say one thing, that if P of A is 0, here the remainder was 0, right? So, I can say that x minus A would be a factor of Px. This is a very important statement, right? And another thing, we can say that if x minus a is a factor of px, we can say that p of a would be 0, right? So vice versa. Yes, Prateek Sharma, amazing. Yes. Sai Arjun, I found this question useful. Thank you. Great. All right. So this was about factor theorem. Now let's take a look at the proof of the factor theorem. So according to remainder theorem, what we learned, the mathematical statement says that p of x would be equal to x minus a times qx plus pa, right? Now, when the remainder is 0, that means P of A is 0. So, I can say that here this is 0. So, that would be equal to Px is equal to x minus A times Qx, right? So, I can say that here x minus A is a factor of Px, right? It will completely divide Px. This is what it means. And since x minus A is a factor of Px, I can say that here in this polynomial, if I put x minus A is a factor of Px, I'll put x minus a equal to 0, x would be equal to a. Instead of x, I'm going to put a over here. So, a minus a is 0, this will be equal to 0. That means in that case, the remainder is going to be 0. Yes. Vishal, the explanation was great. Alright. Amazing. Prateek Sharma. Somalia, understood. Eshika Tripathi, this is easy. Alright. Okay. So, now let's take an example to understand the factor theorem. So, we have to check here whether x minus 2 is a factor of the polynomial. This is the given polynomial that we have. Now, to check this out, what we need to do is, first, since we have to check whether it is a factor, let's find out the 0 of this. So, I'll equate this to 0. What do we get? We get the value of x as 2. Alright. So, this is the polynomial that we have. In place of x over here, I'm just going to put 2. So, we have 2 over here. This is 2 actually, right? So just simplify this. Wherever you have x, you put 2. What do we get from here? We get that f of 2 over here is going to be 0, right? So when I put it here, I see that it is going to be equal to 0. That means x minus 2 is actually a factor of the polynomial. Since it is completely dividing it, the remainder is 0 over here. Yes, Papiya Das, okay, Deepak, easy peasy. Alright, let's take a look at another question. Using factor theorem, determine whether gx is equal to x plus 1 is a factor of px, 2x cube plus x square minus 2x minus 1. So we have to use factor theorem for this, right, to check this out whether it is a factor or not. So this is the given polynomial and this is actually the divisor. But when can I say that it is actually a factor of this? When the remainder is 0, right? So to check this out, let's use factor theorem. So the 0 of x plus 1 would be equal to minus 1 once you equate this to 0. Alright. This is the given polynomial. Now instead of x, I'll put minus 1 over here, wherever we have x. What do we get? We get minus 2 plus 1 plus 2 minus 1. And at the end, we have p of minus 1. This gets cancelled, this gets cancelled. What do I get? I get 0. That means x plus 1 I can say is a factor of 2x cube plus x square minus 2x minus 1. Saroj Gupta, ma'am, you make maths easy. Thanks. Wow. Great. I'm glad that you find it actually useful. Alright, so what we have done here is simply I just found out the 0. I just found out the value of x from here, right? And we put it in place of x in the entire polynomial. When we get the answer as 0, that means it is actually a factor of the given polynomial. Yes. Alright, let's take a look at another question. Now in this question, we have to find out the value of this missing variable k. We are given that x minus 3 is a factor of this polynomial, k square x cube minus kx square plus 3kx minus k, right? So what we will do is, first of all, using the factor theorem, this is the given polynomial. Let's assume this as fx. Now let's find out the 0 from here. So 0 of x minus 3 would be 3 over here, right? Alright, so let's put 3 over here wherever we have got x, okay? So we get 27k square minus 9k plus 9k minus k equals to 0. Why am I putting it equal to 0 this time? Reason being, question itself says that this is a factor of this given polynomial, right? So that means once I put 3 in place of x, the entire polynomial should be equal to 0. Yes. Alright. So this gets cancelled. We have 27k square minus k equal to 0. Let's take k common. What do you get? You get two values, k equal to 0 and 27k minus 1 equal to 0. That means at the end we will have k equal to 0 and k would be equal to 1 by 27. That would be the final values. Yes. Yes. Papiya Das, ma'am, here we have quiz time. No, not here. That is in grade 10th actually. We are starting it with grade 10th first. Alright. So these are the values of k. Now we will try to understand how to factorize a given polynomial, a given quadratic equation, right? Like this is the general quadratic equation that we have, ax square plus bx plus c by, so we are using the method of middle term splitting here. So how to do middle term splitting? Let's first take a look at the general expression, like how to apply this in a general expression. This is the expression that you have. Now what we do is, this is the middle term b, right? So basically what we are doing here is we split the middle term as a sum of two numbers, let's say, which are p and q over here, such that their product is equals to a times c. That's what we do in middle term splitting, right? Yes, Anshuman Tiwari, is it 0 and 1 by 27? The previous question, yes, these are the values for k. Yes. Alright. Vishal Day, 9kk, what is 9kk? I didn't get your question. Alright, okay. Now let's take an example to understand this. Suppose we have to factorize x square plus 5x plus 6 using the middle term, right? So first we will try to understand the method of factorizing quadratic equation by factorization. So this is the expression that I have here, x square plus 5x plus 6. So let's make use of Cartesian plane over here. So before I tell you the exact answer here, let's try to understand this, right? Anvi Sharma, ma'am, your teaching method is interesting. Thank you, Anvi. Alright, so this is the Cartesian plane that we have. So we have three terms over here, x square, 5x and 6, right? This is the first term, that's second term, that's third term. So to understand this, let's first see how this expression has been formed. Let's take a square of side length x units, right? So this is x, you can see on the screen, right? So the area of this square would become what? That would be x square, right? Right? All right. Ma'am, A is equal to 1, PQ equal to C directly. A equals to 1 when PQ is equal to C directly. Yes, when A is equal to 1, then only you can say PQ is equal to C, because you will put it there, right? Exactly, Abhijit, that would be x square, right? Now let's see how this 5x has come up, right? So let's take a rectangle of length, height 1 unit and breadth 5 units, right? Okay. So these are the rectangles that we have. So the area over here will become x square units, because length time breadth would be equal to x square units. So let's add all them up. So what do I get? I get 5x, right? So the area of square is x square and the area of these rectangles is 5x. Let's add them up. We get x square plus 5x. Now coming to the third term that we have 6, let's take a rectangle of length 1 unit and breadth of 6 units, right? So the area would be 1 times 6, 6 square units. So this could be written this way as well, 3 times 2, right? When length is 3 units and breadth is 2 units, still the area would be same, right? Now if I adjust it this way, right? If I shift 3 rectangles over here, still it's going to be the same, right? Okay. Now let's merge this rectangle with the previous figure that we have, and we can see that it was actually missing from this part, right? So what do we get at the end? We get a complete rectangle, right? Which has a, you can see the dimensions. This is x plus 2 and this is x plus 3, because this side length is x, right? And this is 2. So this is also 2, that becomes x plus 2. This side length is x and this is 3, so that's x plus 3, right? So this could be written as x plus 2 times x plus 3. So this method is basically known as middle term splitting. Sorry. Ishika, x square plus 5x. Sonali Day plus 5x. I can still see the comments of like a couple of seconds before. Can we have more comments, please? Sonali Day, east or west, BYJU'S is best. Yeah, thank you. Yes, okay. Now let's take an example to understand this. So we have to factorize x square minus 2x minus 8 using the middle term splitting. So I would suggest that you all also try doing it along with me. Alright, so we have x square minus 2x minus 2. This is the polynomial that we had. So what I have to do here is, first, simply the coefficient over here is 1. First we see that it is in the standard form. Let's multiply them. I get minus 8x square, right? So minus 8, just forget x square, factors of 8, right? Factors of 8 are 4 times 2, 1 times 8. It could be written as minus 4 times 2 or minus 2 times 4, minus 8 times 1 and minus 1 times 8. So out of these 4 pairs, I can pick only one pair, such that on adding or subtracting them, I get minus 2. So what do I get from here? That's going to be minus 4 and 2 only. Because if I add them up here, this is minus 7. If I add this up, positive 7. If I add this up, you get 2. So whatever pair you pick up apart from the first one, you're not going to get minus 2. So here if I add them up, I get minus 4x and plus 2x. Okay, so let's take common from here and here. So from here I get x common. We have x minus 4 inside. From here we have positive 2 common. So in this step, many times I've seen that students make a mistake. They do not write the sign along with it. They would just write down 2. Do not forget, whatever sign it has, you have to copy it here. Okay. Yes, Papiya Das, ma'am, you make maths interesting. Thank you. Yes, Deepak, it's a part of 10th standard. See, this is very basic. This is something that you are going to use in further classes also. Alright, so x minus 4 plus 2 times x minus 4. This is what we are going to get, right, once you take common. So the factors that we have from here is x plus 2 and x minus 4. So these are the factors of this given polynomial over here. Sonali Day, ma'am, I am Bishal joining from another ID. Alright. Alright. Purva, not understood this question. See Purva, all you have to do is first check whether it is in the standard form. Then you have to multiply the constant term and the coefficient of this very first term. You get minus 8x square. You make all the pairs, right? Once you have all the pairs, then you need to think which pair I can pick up so that when I add it or I subtract it, I should get minus 2. You can check with all of them. You're not going to get minus 2 except this pair, right? So once I added them up, minus 4 and plus 2 will give me minus 2, right? So we can write here minus 4x plus 2x. Now if I take common from here, what do we have common? We have x common. Inside the bracket we will have x, negative sign as it is. Since I have taken x common, so we will have 4 over here. Yes. If it is not in the standard form, first arrange them in the standard form. Write it down in the standard form first. Right? Standard form is from higher degree to lower one. Yes. Deepak, your teaching is useful to me in my exams. Right? Great. Thanks a lot. Yes. Yes, Purva, I'm explaining it again. Right? So this becomes minus 4x plus 2x. So you take x common from here, you get x minus 4. From here I can see positive 2 is common. You just have to copy this sign here. So inside we have x, negative sign as it is. 2 times 4 is 8, so I'll write 4 here. So one factor is from this x plus 2, another is x minus 4 as it is. I hope, Purva, it is clear to you now. Yes? Diya, ma'am, your explanation is well understood. Thank you. Great. Thanks a lot, Diya. Yes. Alright, now let's take a look at the another method here. So we have to factorize 6x square minus 30x plus 36 by factor theorem, right? So there are a couple of steps that we need to follow for this. First step is we have to check the coefficient of the variable with highest exponent. The variable with highest exponent is x square over here, right? Yes. So its coefficient is what? Here the coefficient of variable with highest exponent over here, that's going to be actually that's actually over here is 6, but here we have to make it 1, right? So what we do here is simply I'll take 6 common. So what do we have inside? We have x square minus 5x plus 6. This becomes 6 times px. Let's assume that this is 6x. This is px. Yes. Alright. So this is the polynomial that we have now. X square minus 5x plus 6. You can do it with this as well, with the given polynomial also, but in that case, you know, the digits are very big, and so in that case I would suggest first you take common from here. Alright. So now we just have to find out the factors of 6. So this is the constant term over here because we picked the constant term only. So we have plus minus 1, plus minus 2 and plus minus 3. These are the factors of this constant term, that is 6 over here. Alright. Now here we are just going to apply hit and trial method. So what we are doing here is, this is the given polynomial that I have, x square minus 5x plus 6. One by one I am going to put all these values here. So wherever I get 0, that value would be that given value would that actual value of x would become the factor, right, with the change sign. So here what I'll do is, first let's suppose I put one by one, I'll put 1, I'll put minus 1. You can try with all of them, but when I put 2 over here I get 0. That means I can say that x minus 2, do not forget to change the sign, would be a factor of this given polynomial. Yes. Alright. How to verify that these are the factors correct in middle term splitting? Again, put it again, that let's suppose you got, let's suppose in the previous question, I think, I don't remember the actual value, maybe we got, let's suppose 2, we got minus 2 and we got 2 and plus 4, right? So whatever values we have, let's put that value of x again in the given expression, and if you get the value as 0, that means your factors were correct in that case, right? You can find out the 0 in that case. Yes. Alright, like I can show you here in this question also. So if I put 3, see we are doing the same thing what you just asked. Yes. Alright, so if I put 3 over here, again and again, like we will keep putting values. If I put 3 over here, so we get 0. So I can say x minus 3 is a factor of this. Let's suppose for this polynomial, you get the factor as x minus 3. So how to check whether it is a factor or not? So equate this to 0. You get 3, again put it in place of x, you get 0 at the end, that means it is a factor. Yes. Alright. So by hit and trial method we got that these are the two factors for it. Now remember one thing, that number of factors for a polynomial would be less than or equal to the degree of the polynomial. So what is the degree of polynomial over here? That's 2. So number of factors that we get from here, that's going to be less than or equal to this. Alright, now let's take a look at another question to understand this. Yes. So we have x cube minus 2x square minus x plus 2 using factor theorem. We have to factorize this. Okay. So what I'll do is, first I see that the constant term, it is in standard form, the constant term over here is minus 2. Let's find out the factors of minus 2. That can be plus minus 1, plus minus 2. So you have to consider both the signs every time. So let's find out 0 from here. One by one we check for all of them. X minus 1 is equal to 0, so x would be equal to 1. Let's put 1 in this wherever we have x. So what do you get? You get plus 1, plus 2, minus 1, minus 2. All this gets cancelled out. You have 0. I can say that x minus 1 is a factor of fx. Do not forget to change the sign here. It is x minus 1. Yes. Alright. So x minus 1 is a factor of fx over here. Now, similarly, for x plus 1, I equate this to 0, I get x equals to minus 1, I'll put it here. So what do we have? We get this, we put it here in place of x, this is equal to 0. I can say that x plus 1 is a factor of fx. You just have to change the sign over here, right? Similarly, for x plus 2 also, you get x equals to, right, minus 2, right? So we get minus 2 cube plus 2 times minus 2 square, minus 2 times minus 2 here, and we get at the end 0, so x plus 2 is a factor of fx here, right? And then similarly, x minus 2 would be equal to 0, so x is equal to 2. Put 2 wherever you have x. So we can say that x minus 2 is not a factor of fx, right? So fx, I can say we have got 3 factors over here, x plus 1, x minus 1 and x plus 2. See, number of factors I told you would be less than or equal to the degree of the polynomial. It's a cubic polynomial. The highest power over here is 3. The degree is 3. We've got 3 factors over here, right? Soumya, this class are just amazing. Anyone who is willing to learn BYJU'S becomes the best companion. Wow. Thank you, Soumya. Alright, so these are the 3 factors for this polynomial. Well, this was the last question from today's session. But don't worry, this is not the end. We have lined up many more sessions from you from every Monday to Friday to make you exam ready. So our next session is on algebraic expressions and identities, which is on January 4, that is Tuesday at 5 p.m. And if you want to have access to more such great content, then please click on the link in the description box below, and you can get your doubts clarified instantly during the class. Yes. Waiting for another session. Yes, I am waiting for the another session too. Yes, Amna, Mazal, do we have? Sorry, I couldn't read the entire comment. Yes, Arjun, it was a great session, ma'am. Thank you, Arjun. Yes, Lavjeet, your teaching is really helping us. Thank you. Thank you, Lavjeet. Yes. All right. Yes, session is interesting. Thank you. Thank you. All right. So with this, finally, I bid farewell to you guys. But yes, we will meet very soon. Thanks a lot. Goodbye.